Hello everyone, this video is for lesson 20, parallel lines, day 1, and we are going to start with this basic question. If you take a look at what we have here, we have parallel lines. We know that because of these two symbols here, and they are being cut by this red line. This red line is actually known as a transversal. So what we have here are parallel lines cut by a transversal. Based on this diagram, there are relationships that occur. So we're going to start by just discussing which angles have the same measure. So there are 8 different angles that we have labeled along the transversal as well as along the parallel lines. We're just going to come over here and we're going to list which angles appear to have the same measure. And to do that, it might be easier to kind of classify them as the angles that are acute and the angles that are obtuse. Remember, acute is that angle whose measure is greater than 0 but less than 90. Obtuse is that measure who is greater than 90 but less than 180. So the acute angles appear to be the angles here, 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 and here. So our acute angles are going to be angle 2, angle 3, angle 6, and angle 7. Okay, and then we're going to have our obtuse angles, and those angles are going to be the angles here, 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 and here. So our obtuse angles are going to be angle 1, 4, 5, and 8. Now, honestly, if you can recognize that 1, 4, 5, and 8 are all obtuse, and 2, 3, 6, and 7 are all acute, truthfully, that's the entire lesson. What we're going to now do is we're going to get a little bit further, and we're going to say, well, what's the relationship? What do I call angles 1 and 5, right? Why do they have the same measures? Why do angles 3 and 6 have the same measures? And 2 and 3, we know why angle 2 is congruent to angle 3, right? Those are vertical angles. We know why 5 and 8 are congruent. Those are vertical angles. So we're not looking for vertical angles. We're not looking for linear pairs. We're looking for new angles that occur. So before we do that, we have to talk about when we have parallel lines cut by transversal, which right now I don't have parallel lines, right? I know my lines are parallel when I add a set of arrows. So let me do that first. So here are my arrows to show that these lines are parallel. Okay, so once I have my parallel lines, there are a few relationships, there are a few areas that I want to discuss. And the first area, by accident, I kind of showed is called the interior. So in between these parallel lines, everything in between here, this is known as the interior, right? So I'm gonna maybe take this and I'm gonna just do this. This is all known as the interior. Everything in between here, all interior. Okay. Now, as soon as I go outside, it's known as the exterior. There's exterior up here and down here. So you have interior, inside of the parallel lines, and then you have exterior, that's outside of the parallel lines. So we could even go as far as now saying, okay, everything out here, this is all exterior, right, all this. And then everything down here is exterior. Okay. So that's what we're talking about, interior and exterior. So if we're discussing a specific angle and we say, hey, the angle is interior, that means it's inside the parallel lines. If it's exterior, that means it's located outside the parallel lines. Now you'll also see in all of these questions when we're talking about parallel lines cut by a transversal. So the transversal is actually the line that cuts through both the parallel lines. I think we would all agree that a transversal has a left side and a right side. So you could be on the left of the transversal or the right of the transversal. Okay. Now, we're going to start with something like this. There's a theorem. So based on parallel lines cut by a transversal, there's something that was proven. It's known as a theorem. So to discuss this theorem, we're first going to describe where are angles 1 and 2 located. So we just said, okay, well, we have interior and exterior. So 1 and 2 are definitely interior, right? I think we would all say they're inside the parallel lines. They're inside the lines right now. Now, 1 is on the left, right? And 2 is on the right. So it looks like we have interior angles, 1 on the left, 1 on the right. So if you think about when I say left and right, we're alternating. One's on the left side, one's on the right side. Some people would say one's on the top and one's on the bottom. Now, we don't discuss top and bottom in terms of the transversal because one could be up here and that could also be the top. So we say left and right. So now these angles, 1 and 2, if you take a look at them, they're both acute angles. So what do you think? Well, they're actually going to be equal. So we know that angle 1 is actually equal to angle 2. These are known as alternate interior angles, and they are equal. The same goes for angle 3 and angle 4, right? They're alternate left and right interior angles. So the theorem that we say is if we have two coplanar lines cut by a transversal so that the alternate interior angles are formed, then these lines must be parallel. So if these angles are congruent, these lines have to be parallel. Now watch this. If I take angle 2, and right now it's acute, and I make it obtuse or a larger acute, are these lines parallel? And you would say, absolutely not. Well, that's what this theorem is stating. If these angles are congruent, the lines must be parallel. So we then know over here, what are our alternate interior angles? So we can make the statements now. We can say that the measure of angle 1 is equal to the measure of angle 2. And we know that the measure of angle 3 is equal to the measure of angle 4. And those are your alternate interior angles. Now, another word that you see here is coplanar, and it just means that these two lines are on the same plane. Meaning if we were kind of in 3D right now, I would have one line, I can't have one line going kind of front to back and one going side to side. They would both have to be going in the same direction. Okay, so again, this is the big thing over here that we can take away from this. The angle 1 and 2 are equal as well as 3 and 4 because they're alternate interior angles. Okay. All right. So now here's also what happens. If these angles are congruent, the lines are parallel. But we could also say if the lines are parallel, the angles must be congruent. Okay, so it's known as a converse. It works both ways. If I have congruent angles that are alternate interior, I get parallel lines. But if I have parallel lines, I also get the congruent alternate interior angles. Okay, so it works both ways. So now let's take this and apply it. In just a second. We have to talk about these first. Sorry about that. So now take a look here. And what do you notice about 1 and 2? Now, they're exterior angles, right? Because they're outside. So just type exterior. We have exterior angles. That's for certain. And again, they're alternate, right? One's on the left and one's on the right. So we have alternate exterior angles here. Let me just mark them. They're going to be equal as well. So these are my two acute alternate exterior angles. They're equal. Likewise, I can put this angle here congruent to this angle here. Okay, so I would know here if these lines, actually if these angles are congruent, they're alternate exterior angles, these lines must be parallel. So we can say angle 1. And now remember, congruent and equals are the same, right? So if their measures are equal, they're also congruent. So I always like to go with the measures of the angles because right here in the theorem, you're seeing that they're congruent. So angle 1 and angle 2 are known as alternate exterior angles, left side and right side. Think of alternate. Alternating days, A and B, right? Okay, the theorem now has the converse. Obviously, if we have congruent angles, we get parallel lines, but if we have parallel lines, we also get congruent alternate exterior angles. Okay. So here, to take away, we know that we have alternate exterior angles equal. This is what we're doing. We're just working through some relationships. And if you look back up to do now, we said that these angles were on the acute list and they're all equal, and that's correct. Okay, so now let's do an example. So here we have a diagram, and the first thing you always want to make sure that you're looking for is what is your diagram telling us? So right now our diagram is telling us that we have parallel lines. And I know that because of the symbol right there. Right? If I didn't have that symbol, I wouldn't know that my lines are parallel, but I do, so I know they're parallel. So now I ask myself, okay, if I have to find x, I have to write an equation. But before I can write an equation, I have to decide, well, what's going on here? So look at my angles, okay? Both angles look to be obtuse. So in my mind, I'm identifying. If they're both obtuse, they have to be equal. But I need a reason why they're equal. So why are these angles equal? So then I go by location. Where are they located? Well, they're interior angles. One's on the left and one's on the right, left and right. So these are equal angles, not because they're both obtuse, but because they're alternate interior angles. So alternate interior angles are equal. So now I could go ahead and I can write an equation. And I would take my two expressions, because think about it. If this angle was 100, this angle would have to be 100. So whatever this angle is here, this angle is equal to it. So I know that 10x plus 45 equals the other angle, which is 3x plus 87. Okay, so now I would work to draw my line down the middle. I would subtract. After I subtract 3x, I would get 7x plus 45 equals 87. Then I would subtract 45 from both sides. I would get 7x equals 42, right? And then I would divide by 7, and I would get x equals, and that would be the value of x. So here x would be 6. Now, remember, I could quickly check my work. I could go up here and I could say, okay, so 10 times 6 plus 45. Well, that's 60 plus 45. This would be 105. And over here, I could do 3 times 6 plus 87. That's 18 plus 87 is also 105. Okay, so you could always plug back in and check your work. But at the end of the day, x equals 6. Okay? That's how this is what we're going to, this is our goal. We're going to work towards applying the relationship, creating an equation, and then solving. Now look what we have here. Okay, again, we have parallel lines, right? I need to make sure I identify that I have parallel lines right away. So they're parallel, okay? Again, they're both obtuse. So I know if they're both obtuse, they have to be equal. So I can mark that. Okay, so now they're definitely equal because they're obtuse. But really, what's really the reason why they're equal? Well, now this is a case where sometimes you might want to just take your paper. You might just want to turn it. Oop. Right? If I just turn my paper very quickly, it might be easier to see what you have, right? I have exterior angles that are on opposite sides of transversal. So these are known as alternate exterior angles. And we know that alternate exterior angles are equal. So then you write yourself your equation. That means that 115 equals z plus 85, right? This angle is equal to this angle. Subtract your 85 from both sides, and we get that z is equal to 30. And we are finished. Okay? All right. So continuing on, we talked about alternate interior, alternate exterior. Now let's take a look at something else. And it's this here. Now, we had said in the do now, you can kind of decide which angles are going to be equal or which angles are obtuse and which angles are acute from the get-go, from the start. So with that being said, there's a reason why so many angles wind up being the same measure. So take a look here. A pair that we said that were acute, 1, 3, 5, and 7. So if I look at 1 and 5, and I'm going to take this bottom piece, and it actually slides. Watch what happens. I know for sure that 1 and 5 are equal, right? I can take it. It's like tracing. I can take this, and I can slide it up, and 1 and 5 match up, right? Now, I'm saying that these angles are matching. So I want you to think in terms of like what matches up. Right? If I slide the top to the bottom or the bottom to the top, what kind of falls on top of each other? So we said, okay, so we said angle 1 and angle 5, right? What else slides up? Well, we can say also then that, hey, 2 and 6, right? We said angle 1 and angle 5. We also have angle 2 and angle 6. We also have angle 3 and angle 7, and we have angle 4 and angle 8. Now we said that they match up, but they're also equal, right? These are equal angles. They completely lie on top of each other. So these are called corresponding angles. So if we have corresponding angles that are congruent, then the lines are parallel. So here is your list of corresponding angles. And they're equal. Okay. So think about which ones kind of match up. Corresponding angles are congruent. Converse again, if you have your parallel lines cut by transversal, then the corresponding angles are indeed congruent. Okay, so corresponding angles are really important to kind of remember and look for, right? You have to remember those corresponding angles. Now, let's take a look here what we have. Now for this, I'm right off the bat, I like to look at my parallel lines like this, just the way I prefer to look at things. And right away, I would like us to, we're going to determine the value of each variable here. There's A, B, and C. But I really want to work on corresponding angles. So the way I kind of think about this is here I have the bottom part of my parallel line. Now if I take this and I slide it up, it becomes this. So what are my corresponding angles right away? And right away, I see if B is up here at the top right, and I slide this up, top right is 48. So I know that B's measure has to be 48. And the reason would be is that it corresponds to 48 degrees, right? B corresponds to 48 degrees. Now, A and C also correspond, right? If I look here, C is the bottom on the right, so is A. So I have to figure out what's A. Well, now I take a look, and maybe this isn't a parallel line theorem, right? I think A and 48 here to here, they're adjacent angles on a straight line. Right? They're a linear pair. So I know that I have a linear pair with A and 48. Oh, what happened here? Hold on 1 second. Got a little messed up. Okay, so here's the reason there, right? Linear pair, so I have A plus 48 equals 180. So then I can easily solve, subtract 48 from both sides, and A is 132 degrees. Okay, now we said A and C are corresponding. So I know that C has to be 132 degrees because it corresponds with A. There you go. We're done. That's how it works here. Right off the bat, I could have said, hey, 48 and B both acute, A and C both obtuse. I would know that B and 48 have to be the same as do A and C. Okay. All right. So now into just some basic questions applying what we just were discussing in terms of alternate interior, alternate exterior, and corresponding angles. All those relationships do say that those angles are equal. So we're going to look at a diagram, and it says with line P and M, P, M, and N, P runs through both M and N. Now we want to know if the angle at 1 is 7x, so this is what you always have to do, right? You have to make sure you fill in your diagram. So angle 1 is 7x, angle 2 is 5x plus 30. These lines are parallel when x equals. So how do I know what would make these lines parallel? And these lines would be parallel if your alternate interior angles were equal. So if the alternate interior angles are equal, the lines are parallel. Okay, so that means, hey, I'm going to assume I want to make these lines parallel, so I have to set these equal to each other, right? So I would have to take this, and I'm going to write myself an equation to solve. I can now find the measure of x. I can say, well, if I want them to be equal, I just set them equal. 7x equals 5x plus 30. Right. Subtract 5x on both sides, we get 2x equals 30, divide by 2, and we have x equals 15. And so your answer would then be choice 2, x equals 15. So we want them to be parallel, so the alternate interior angles would have to be equal. Therefore, I set them equal and solve for x. All right, number 2. Now they're telling us that the lines are parallel. So all the relationships that we know, and I'm just going to run through them quickly. That means alternate interior angles are equal. Alternate exterior angles are equal. That means corresponding angles are equal. That means that we could have a linear pair, right? Now, I'm not going to put them over here. These deal with parallel lines. We also have linear pairs come to 180. And we also have vertical angles are equal. So two different things, right? Because I could have linear pairs without having parallel lines. So they are parallel, so I'm going to mark that. That means all of this information is true. So now I need to fill in that angle 2 is 3x plus 17, and angle 3 is 5x minus 21. Now, personally, I like to say I have to create an equation with just these two angles first, right? I'm going to leave angle 1 out of the picture for a second. That's my goal. I want to find angle 1, but I'm going to deal with angle 2 and angle 3 first. So angle 2 and angle 3. Now notice I'm only talking about this line here. So none of these parallel line theorems are going to apply. I'm going to deal with these over here. So if two angles on a straight line, these are in fact a linear pair. So these two angles must sum to 180. So it's going to be my first equation. My first equation is going to be 5x minus 21 plus 3x plus 17 equals 180. Okay? And I can combine like terms and I can solve. And there we go. So when I do that, I get 8x minus 4 equals 180. Add 4 to both sides, so 8x equals 184. Divide by 8, and I have x equals 23. Okay, so what I use here is that I have a linear pair. So measure of angle 2 and angle 3 are linear. Okay. And that's why I was able to write this equation, 5x minus 21 plus 3x plus 17 equals 180. So let me draw this down. Okay, so that's the first thing. Now I know that x is 23. So I'm going to go back up here and I'm going to say, well, if I know the value of x, I could easily find both angle 2 and angle 3. My goal, though, is to look for angle 1. So here's angle 1. Now remember, angle 1's on a different line. It's on a line that's parallel to this line up here. So what is angle 1 equal to? Angle 1 is equal to angle 2. Angle 1 and angle 2 are corresponding angles. So now I know angle 1 and angle 2 are corresponding angles. That means that angle 1 equals angle 2. Well, angle 2 is 3x plus 17. That means that angle 1 equals 3x plus 17. And we know x is 23, so angle 1 is equal to 3 times 23 plus 17. Oh, so then I just have 3 times 23 is 69, 69 plus 17. So the measure of angle 1 is equal to 86 degrees. It has a little measure in front of it for all these because we're talking about equal. That's how it works. Right, so I use my linear pair relationship because we're talking about just one of the lines. And then I say, well, how can I tie it into angle 1? And angle 1 is on a different parallel line. So I look for a relationship with angle 1 and one of these angles. So angle 1 and angle 2 are equal because they're corresponding angles. So if angle 2 is 3x plus 17, well, so is angle 1. And x was 23, so I plug it in, and that means that my answer here is choice 4 at 86. Okay? All right. Moving on to the last question, which is this one right here. It says the diagram below shows the construction of line M. So this line is somehow being constructed. And it's parallel to line L through point P. What theorem justifies the parallel line construction shown? So first, what construction is this? If you look at what's happening here. And it looks like they are copying an angle. So the construction that we have here that they're working with is copy an angle. Okay, now think about what kind of angles did they just construct. They're congruent, right? And it's this angle here and this angle here. Okay, so they're not alternate. They're on the same side, right? One's on the bottom and one's on the top. These are corresponding angles. So the parallel line theorem that we're going to apply here is this. If two lines are cut by transversal and the corresponding angles are congruent, they are parallel. And there we have it. Okay, so that really does finish up the first day of parallel lines. If you're taking anything away from today, it's that we talked about alternate interior, alternate exterior, and corresponding angles. And all those relationships, when those angles are congruent, the lines are parallel, and vice versa. If we have parallel lines, those angle relationships hold true. If you have any questions, please feel free to reach out through email or the Google Classroom.